This week, learn how to make your programs a little bit more graceful in their error and exception handling by asking for forgiveness instead of permission. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer at Unidata. On this week's MetPy Monday, I want to show you some tips on handling exceptions in your programs. It can increase runtime. Instead of asking, can I do this, asking permission, you ask for forgiveness of I tried this and it didn't work, so here's a way to handle that exception. I'm going to start out with a pretty simple and contrived example, and then we'll go to a little bit more real-world example. So I'm here in my notebook, and I'm going to create a list, my data. Let's say these are temperatures or wind speeds or something like that. I think I'm going to call them a temperature, but maybe there's some bad obs in here. Our system got confused and we had an offset in the columns of the file that were written. So maybe the string cloudy gets in here, or some other type of data that we don't want in there. So I'm going to put one more in, sunny. Okay, so there's our data. I'm going to make a result list here. This is not the most efficient way to do this, but it will show our point here. And I'm going to write a loop for observation in my data. I'm going to append to those results. Let's say that I found out my temperature sensor was off by 2 degrees. So I'm going to add 2 degrees to each ob. Well, that's not going to work because it adds 2 to 24, 2 to 35, and then gets to cloudy and doesn't know how to add the integer 2 to the string cloudy. So let's look at another way we could do this. You could manually check, is this an integer? That's a little bit of a pain. So we're going to use a try except block. So same structure here for ob in my data. Now I'm going to say try res.append ob plus 2, except we're going to print not a valid observation, and we will show what that observation was. So now if I run this, you'll see that we get not a valid observation cloudy, not a valid observation sunny. And if I look at res, I have all of the integers offset upwards by 2 degrees. So what this effectively did was say, try to do this, and if any exception occurs, any exception whatsoever, in this case it is a type error, we're going to do this. Now it is best practice to specify what type of exception that you want to catch here. So maybe we don't want to catch any error that's coming from anywhere. So let's just say we're going to catch the type error. It's going to work the same way, but if that was raising some other kind of error, it would actually propagate that error all the way through to us, the user. So that's a nice little example, but let's look at a more real-world problem. Let's say we want to get some data from the National Data Buoy Center. So to do that, we're going to use Siphon. We've talked about this before. So from siphon.simplewebservice.ndbc, import ndbc. And let's look at the types of data that are available for a few buoys. Let's say for my study, I want to use supplemental data from the buoys. I know that the variables that I'm interested in are contained in the supplemental data file. Well, one way to check if a buoy has supplemental data is to use the buoy data types method. So let's look at buoy 46259, which I believe is off the coast of California. So it's going to go out to NDBC, see what types of data are available for this particular buoy. And remember, this takes just a little bit. Okay, so there we go. We've got meteorological data, spectral wave summaries, and some spectral wave data. No supplemental data. Okay, my next buoy, NDBC, buoy data types. Let's use buoy 45002. Okay, so that buoy has come back, and it does have supplemental data. So let's say I had a list of buoys that I wanted to do this on. Well, we don't want to necessarily have to check every time. So let's see what happens if we request supplemental data from a buoy that doesn't have it. So data frame is going to be ndbc.realtimeobservations, the buoy number. So let's go 46259. And the data type is supplemental. So if we get that, we see an HTTP error. It says that this file does not exist, 404 not found. So we don't want to have to do this every single time. We don't have to check the data, and we need some way to deal with this error. So let's look at the naive way to do this. First, we'll get our list of buoys. So 46259 and 45002. We'll just do 2. I'm going to time this cell to show you how different these two methods are. Now, doing the % time is a cell magic. So single % sign is a line magic. 2% signs is a cell magic. And this will tell us the time that this cell took to execute. So I'm going to do this as a loop. For buoy in buoys, we're going to check the data types. So you can use ndbc.buoy data types for our buoy. Okay. If supplemental is in data types.keys, so that's checking if that supplemental file exists in that list that's returned, or that dictionary that's returned rather. Then we'll print doing supplementary analysis on buoy. And we'll print the buoy number. And we'll go get that file. So df is ndbc.realtimeobservations. Buoy and supplemental. Okay, and if not, so if else, we're going to print no supplementary data for buoy. Like that. Okay, so let's run this cell and see what happens. Now remember, for each buoy in that list, so 2 in this case, it's going to have to go out, get the data types, which we saw take several seconds for requesting all these different data types from NDBC and seeing what happens. So no supplemental data for that buoy. Now it's going and checking buoy 45002, which we know should have supplementary data. And okay, so there we go. We're getting a warning from pandas, but that's okay. So we're seeing here about 25.2 seconds. So that's quite a while for just 2 buoys. That's over 10 seconds per buoy. What if we just tried to get the supplementary data and handled the exception, that HTTP error that comes up? Now, this is actually what Siphon does internally when you're trying to see what data types are available for a buoy. But we can do it straight in our script here, or you could catch any other of numerous errors that come up in your programs when you're doing large automated analysis. That's where this is really useful. Or handling user input, let's say. So I'm going to time this cell again. I'm going to import the requests library, so I have a way to get a hold of the HTTP error class. So for buoy in buoys, now we're going to use try. We're going to try to get that file. So df is ndbc, real-time observations, buoy and supplemental. And we're just going to copy the same print statement from up here. Save us a little bit of typing. Accept. And we will copy that print statement. And what type of exception do we want to catch? We want to catch an HTTP error, which comes from the requests library. So requests.http error. Now, if we run this, no supplementary data, doing supplementary data analysis, we got 1.9 seconds. So a little over a factor of 10 speed up, because we're not relying on Siphon to go check all those different types of files that could be there for a buoy, and we're doing some smart error handling here. I think this also reads a little bit nicer than if-else blocks. Those can get pretty long in the end. So I hope that you found this useful and that you'll start doing error handling in your automated analysis scripts. It's a way to make sure that they don't crash out in the middle because of a bad data file or a server that's down. It's a way to help make your codes more robust. I'll see you on next week's MetPy Monday.